The shells will melt, the reefs will die, and all this time emissions rise. The ocean life will never be the same. It's time to tell me about the ocean.
I never listened. But you know what? Things are gonna change as of tonight. Everybody put your hands in the air. Everybody put your hands in the air. Oh, MCGB, Tomas Lee, the Heezy. Yeah.
It's hard to calcify.
Calcifiers are really important organisms in the marine ecosystem, and they include things like sea urchins. And I'd like to talk a little bit more about those. So you might ask, what's happening to them? Well, let's find out.
Some sea creatures like clams, oysters, and coral, their shells and skeletons are getting weaker. Okay, you've got bigger problems than easy-to-crack clams? Maybe not if you're among the 1 in 7 people who get most of their protein from seafood. Or if you understand how unstable the world would be with a billion more hungry people. What's weakening the shells? Well, these little creatures are going about their lives scooping up molecules called carbonate ions to be the building blocks of their shells. But when CO2 reacts with seawater, it releases hydrogen ions, which compete with shells for carbonate. With more hydrogen ions floating around in the ocean, our little friends have to spend more energy building their shells and have less energy for finding food. That means it's harder to grow, and more will die off before they get big. So the fish that eat the clams or live among the coral will have a harder time surviving, meaning the fish that dine on them won't have enough to eat, and so we won't have enough to eat.
And that's not all. There's more to it.
Remember those pesky hydrogen ions generated by more CO2? They don't just take away the carbonate ions that these little clams need. They also make the ocean more acidic. It's already become 30% more acidic since we started spewing all this CO2, and it could get much worse. We could change the ocean's chemistry so much that shells actually start to dissolve.
And so you might be asking, what's pH anyway? Let's take a review. The pH scale is from 0 to 14. The lower the number, the more acidic. The higher the number, the more basic. Just a reminder that an acid is something that when you drop it into water, releases H+ ions, and a base is something that releases OH. If you have both in equal amounts, it's neutral.
Okay, everyone, so I want to show you a little bit of a reminder about pH. We use our pH paper to show us a color, which will indicate to us how much hydrogen ion concentration there is in each kind of water. So, hey guys, I want to do a simple test to remind you about what pH can show us. Right here I have a small beaker full of tap water, and I went ahead and put a piece of treated paper, pH paper, into the water. And as you can see, when I compare it to our chart, it's looking at right about a 7, which is neutral. That's what I'm wanting. I look over at salt water, and again I've got my piece of pH paper which I dipped into my salt water, and when you look again, it's at 7. And then when I look over at my carbonated water, what I did was I took a piece of chalk, which is calcium carbonate, the same stuff that's in a lot of our calcifying organisms in the ocean, and I mixed it with a little bit of an antacid tablet, which is going to let off carbon dioxide, right? So carbon dioxide's in the water, calcium carbonate's in the water, and when you look at our pH paper, you can see that part of it is turning it slightly red, which means that my pH has decreased, and I now have a more acidic environment. And that's just a really simple demonstration of what we're talking about here today.
So this is a really nice graphic showing what happens when carbon dioxide enters the water and mixes to form carbonic acid and how it impacts the calcium carbonates. Well, the next question is, just how bad is the problem? pH is a logarithmic scale, which means every time you go down one number, it's times 10. So going from 8.2 to 8.1 is a 30% increase in acid. These graphics show the predicted levels of acid ocean rates up until 2099. And it's not a pretty picture for our marine organisms or for us.
And with 1 in 4 ocean species living in coral reef ecosystems, weaker coral could threaten the foundation of the whole ocean food chain. But why panic, right? Life always seems to find a way to adapt, but it needs time. In a few decades, we might make the oceans more acidic than they've been in 20 million years. It's hard to imagine any ecosystem quickly adapting to that big of a change. But things don't have to get that bad. We've started this problem, and we're going to fix it, beginning at its source, carbon dioxide from burning fossil fuels.
So how exactly do scientists study the effects of ocean acidification? Well, now it's time for you to find out. We're going to spend a little time in a virtual lab doing what scientists really do to look about how sea urchins are impacted by acid levels in the ocean.
The shells will melt, the reefs will die, and all this time emissions rise. The ocean life will never be the same. It's time to change.
Tell me about the ocean. I never listened. But you know what? Things are gonna change as of tonight. Everybody put your hands in the air. Everybody put your hands in the air. Oh, MCGB, Tomas Lee, the Heezy. Yeah, yeah, yeah.